Oh no, class is over. Class is back in session. How's everyone doing? Mubot, I think, will be here by next class, so exciting times. We're going to talk about class here to start. Let me mark this right here. So we'll put, so let's say, I'm trying to think what to call this. Attending class. Okay, so why attending class matters. I'm going to show some stuff here from our videos. So check this out. This is why attending class matters. I'm going to also be sending this out. And I just want you to see this firsthand. Let's go check it out. Now, we just did the data analytics assignment. So with the data analytics assignment, let's pull it up right here. Data analytics 5. Noel, good to see you. Mubot, I think, will be back next class. So stay tuned. Next class, Mubot's going to be here. I got my fingers crossed. We got tech support, and we're getting it escalated to higher levels. So Mubot should be here. So here we are with the data analytics. And I've got a help video. I always try to put the help videos. And here's what I want you to realize, though, because if you come to class, when you hear these things like, what are the conditions? Let's look first. Taking a random sample, the video is going to walk you through that. Getting the correct output, the video is going to walk you through that. And they have conditions right here. Provide all the conditions from the regression from the textbook and notes. Woohoo! I like that. So if you look right here in the video, this is class 12. And if you go right here to the video, what you'll notice is in the video, if you go down to when conditions fail and you click it, you will literally be brought to right there in the video. So here's us talking. We talk about regression. We go through it. I fixed the slides. When did conditions fail? We just talked about all the conditions. And this was literally right here. If you go through the 5 minutes, you can hear about the conditions. 2 quantitative variables, straight enough the line follows the data, no outliers, and plot doesn't thicken. And we go through and we talk about it more, but the 4 conditions, which 3 of them are based on correlation, there's plot doesn't thicken. So you can clearly get the 4 conditions right here with QQ straight enough, no outliers, plot doesn't thicken. You go to the next part of the assignment right here, and you're going to the slope, the intercept, and the R-squared interpretation. You go to the next video that we have or the next class, because we did a lot of review on this. And if you go to review interpretations right here, under review interpretations, you go a little bit forward, and what do you notice? We've actually written out the full interpretations and color-coded everything, so you can see the R-squared, blank percent of the variation in Y is explained by the variation in X. But here's why I really try to do things in class that'll help you. I don't know if you noticed this, Noel, but on the class 14, during class, right here, what did we do? We did a regression predicting price from Carrot. Now, why might this be valuable to someone where we talk about the plot thickening? It is quantitative. We talked about it is kind of straight enough. We did this straight enough. It's kind of straight enough, but it does have plot thickening. There's not really any big outliers. We kind of did all this right here. We made the residual plot for it. Why would this matter where I'm doing price and Carrot? I'm wearing the Spider-Man t-shirt there, all black t-shirts. And then we go through and we interpret for each 1 unit increase in Carrot, we expect price to increase by 8,001 on average. Why would this matter? We do the intercept and we talk about, is it logical? We do the R-squared. 83.6% of the variation in price is explained by Carrot. So we did all of those interpretations. Then we talked about Spider-Man. But we did all of these interpretations. Why would this matter for Data Analytics 5? And the reason it would matter for Data Analytics 5 is these are the variables. These are the variables for Data Analytics 5 were price and Carrot. So I was like, let me try to help you out here, talk through the conditions. This is why I wrote out the stack interpretations. And I was like, let me do this. So if you were in class on this day, we talked through the residual plot. And this is what I try to do in class, is if you come to class, this is me begging you to come to class, you'll often see the work I'm doing in class is either directly or kind of indirectly the work you're doing. And a lot of people wrote on Data Analytics 5, like, independence condition, homoscedasticity, and those are related. A lot of times independence matters more for time series. The interpretation is worth a lot on the exam is also exactly. And we know there's 3 interpretations worth 12 points on the exam, which we repeat that endlessly, that there are 3 interpretations worth 12 points, the slope, the intercept, and the R-squared. And we know how to do them. Blank percent of the variation Y is blank with the variation in X. For each 1 unit increase in X, we expect Y to increase by B1 on average. When X is equal to 0, we expect Y to equal B0. And is that logical? So we put those up, we put them somewhere we can see them. And this is why I really think coming to class is important, because I'll tell you what's on the test. I'll help prepare you. I'll try to get you organized and ready. So I do want you to know if you got this. I'm trying to make this section a little bit short, so I'm not going to go on too much longer. Is I try to do things in class that one will be on the test and two help you do your assignments. So you don't need to be looking things up and be like, am I doing this right? And then you get partial credit. We're like, well, I wrote 4 conditions, but I'm gonna tell you the 4 conditions that we need when it comes to QQ straight enough and outliers plot doesn't thicken. When I say 4 conditions, you say, oh yeah, we need to check the 3 from correlation and the 1 extra for regression related to the residual plot by making the line, making it flat and checking that residual plot, which if you look through our lecture right here, we did a lot of them. There's a residual plot right there. So I can scroll through and find residual plots. I can see the regression model. I can talk about residuals when we find out the slope, the intercept, and we do more interpretations right here. Probably at the end, we're doing R squared, and it's not correlation. Important facts like this that we go over and memorize and repeat. Well, let's do some work. Let's do work. What work should we do, Noel? I'm gonna send that out. I'm gonna ask people to watch this and say, please watch this on the importance of going to class. That's what I'm gonna send out today, is be like, please, please, please watch this, because I really do believe in class. If you come to class, you know what's going on, you understand what we're doing, and you can then achieve. That's the goal. What should we do? What work do we have coming up? What is it time to do? We got a lot. Things coming up. I got a lot of emails. I have a pickup order at PetSmart. Gotta pick up that order at PetSmart. I could pull up some My Pearson. Sounds like Hot Pockets. Hot Pockets. But I want people to be motivated. I want them to realize class will help you out. That's what I really try to let people know, is like, if you come to class, we're gonna review the material, you're gonna get work done, and also you might even hear some test questions. So you never know. But I know it's tough, a lot going on, but it's just tough. You don't come to class, you're like, when's the test? What's going on? What are the assignments? What are we doing? What am I learning? So we want to be in class. I'm hoping I'm going to send out an email begging people for 300 people to be there tomorrow. Maybe I'll seed 1 or 2 test questions in there. I'll put 1 or 2 test questions in there. We got October 17th, chapter 10, which is a tough one. Yeah, 10 homework? Yeah, let's do that. Let's do chapter 10 homework. It's a tough one. Let's go to replace questions. We'll do the full chapter 10 homework over here. It's a tricky one. Here we go. Chapter 10 homework. Let's do it. Let's do it. Might be different. Oh, here we go. Look at this. Let me put in the notes, chapter 10 homework. Oh my gosh, my eyes are like, not today, Brian. Chapter Stat 201, chapter 10 homework, question 1. Why not? We'll mark all the questions. Which matters more about a sample you draw from a population, the size of the sample or the fraction of the population you've sampled? The population is never used in calculations. It's the size of the sample and how we sample it. Those are the 2 things we talk about in the notes. It's that we don't have any bias. It doesn't matter how much, as The Rock would say. Oh, but it doesn't matter, Rock. It doesn't matter. It doesn't matter how much we sample percentage-wise. Of course, there's a 10% rule we're going to get to shortly that goes to oversampling, but it's how we do the sampling and also how much we sample, which controls things like margins of error. Margin of error being the plus or minus on our estimate. So they give some good thoughts right here, but the population size is not used in calculations of statistics. It's just the sample size is used. So it's the size of the sample and how we sample it. And those are just memorization things. It's just also in the notes that it's not the size of the population that matters. So the fraction of population wouldn't matter because that's relative to size of population. Oh yeah, that was an easy one. 1 minute explanation, kind of memorization. Should say what matters more. Oh, it does say what matters more. It says exactly what I thought it would say. The company's annual report, our survey shows, that's a sample, that 84.13% of our employees are very happy working here. Comment on that claim, use appropriate statistics terminology. So they have a sample survey, and thus this is a statistic. This is not a population parameter. Let's bring up some notes right here to talk through it a little bit. We have sample statistics and population parameters. So sample statistics and population parameters. A sample statistic is like when you take a poll of people. This one's kind of confusing. We'll take a look at the answers here in a moment. So things like Y bar are a sample statistic, and also P hat. Meanwhile, things like mu, P, sigma, and I'll draw these two. This would be S. And Y bar is the sample mean, mu is the population mean. P hat is the sample proportion, P is the true proportion. Sigma is the population standard deviation. So the population is when you've collected all the data. Like if you talk to all UT students, you'd have a population, but if you talk to 100 UT students, you'd have a sample. So if someone gets the population, they would have the full size of the group, which is we call capital N, and there might be about 35,000 UT students. Versus if we have a sample, we might only have 100 students, and then we use lowercase n. So you can see up here sample statistics, and you can see down here what we call population parameters. Parameter is just the analogous word to statistic. It means like a number or a calculation, but the true value. So a statistic is an estimate of a parameter that comes from a sample to estimate the truth for a population, which has a parameter as its value. So what value would it be if I went to the registrar and got the GPA of students? If I go to the registrar, so Noel, look at everything on the screen. If I got the GPA of all students at UT, what value would that be on the screen? I went to the registrar and they said, what's the GPA of students? And they said, oh, here it is. That would be called what? So if I went to the registrar and got the GPA of all students, what would that be called for all the things on the screen? Kind of a review question from what we've marked right here. To understand, statistics are estimates that come from samples. Parameters are truths for populations. And then we have things like Y bar, P hat, S, mu, P, sigma. If you went to the registrar and got the GPA of all UT students, it's a parameter. You are correct. And what parameter is it? It is a parameter. So it is a parameter for a population. So parameters are always for populations. You never say population statistic or population sample or parameter. It is a parameter for the population. So which parameter is it? Great job, Catherine, there. And feel free to ask questions if you got them. You are correct. It's a population parameter, and which one? The GPA, the average GPA of all UT students is what? I'll give the answer away in about 10 seconds. So don't worry about, keep taking guesses. You've said nothing wrong. I'm looking for something more specific. They've reported what to us? They've given us the what? Mu. You're right. Yeah, it's mu. They might say this is mu. And then if you were to only talk to 100 students, you'd have Y bar equals like 3.5. And that's an estimate of the true mean. So they would have told us mu if they told us the answer for all students. So the survey result is a statistic because it comes from a sample. Look at population statistic is nonsense. It estimates the true proportion of satisfied workers in the population. Yeah. The sample frame is who we have access to. So this is actually a very good question. We'll click it again. So this is a statistic which estimates the truth for a population. The sample frame is the group of individuals you have access. So if you do the survey on the weekend, you don't have access to the weekday workers. So the sample frame would be weekend workers. The sample frame, once again, being the people you could possibly sample from. The population being the group you are interested in understanding. The sample being the group you have data on. Let me repeat that. The sample is what you get data on. The sample frame is people you have access. Like if you do the survey on the weekend, you can only talk to people who worked on the weekend, even if you're interested in all people who work at the company. The population being all individuals you want to understand, which could be people you don't have access to, which causes problems of undercoverage. So a really good question right there. A lot of important stuff, and to understand the small differences between like populations, sample frames, samples, sample statistics, population parameters. This chapter is basically memorization. Okay, let's look over the next one right here. And Catherine, if you got questions to ask, or if Noel, you got questions to ask, here's the next one. We're doing review also while doing this to make sure we know the concepts. So make sure to take notes. Let's do it. You are trying to study the amount of financial aid students at your university receive. You sample 50 students. That's a sample size of 50, lowercase n equals 50. And find the average size of the financial packages you receive. The average of your sample is a what? Can anyone tell me? So look at the notes we just took. The average of your sample is a what? You can even tell me the notation. So can you tell me what it is? The average of your sample is a what? And you can even tell me the notation. Don't look at their answers. The average of your sample is a what? And you can also tell me the notation of it. The average of your sample is a what? You can even tell me the notation. It is y bar, and y bar is a sample statistic. So it would be a sample statistic, and it'd be specifically y bar. Great job. Yep, it'd be y bar, which is a sample statistic. Like, once again, y bar is, there's more sample statistics than y bar, p hat, and s. There's lowercase n as a sample statistic too, the sample size. But those are examples of sample statistics right here. So there you go, and we'll highlight this. We'll go boop. Those are just examples of sample statistics and population parameters. Well, that was an easy one. That was basically what we've been doing. These are not that bad. I think we changed these up. I think we made the quiz different because I swear it's easier. Man, this quiz used to be a lot tougher. Where's the really tough, grueling questions? We'll probably get to some. A company hoping to assess its employee satisfaction by assigning computer-generated random numbers to each person on a list of all employees and then contacting all those who are assigned a random number divisible by 15. Is this a random sample? Yes. The problem with this one is people think, well, you're contacting people who have a number divisible by 15, so that's not random, but it is random because everyone was assigned a random number. I can answer that in a moment. No, I'll answer right after this one. Good question. So everyone has an equal and likely chance to be picked in a simple random survey. It's kind of like if you think where you have that ball machine and you roll it and you take a ball out. That's a simple random selection of the balls that exist. And this is definitely a simple random sample because everyone gets a number, and then the numbers we pick, it doesn't matter. It doesn't matter if we do the first 10 even, because everyone was given a random number. So the people you pick, even though they're separated by 15, are still random. So that tricks a lot of people, I think, because you're like, well, it's divisible by 15, so it's not random. Well, it still is random because everyone got a random number. So the answer to your question is yes, you can use them both together. Good question, Noel, right there. Because if we have something like, let me go here to the Pokemon data set, and we would take a sample of the Pokemon, here is a random sample of 50 Pokemon. So this is lowercase n equals 50. Here is, tell me, what is y bar for attack power? What is y bar for attack power? So look at the screen, and what is y bar for attack power? What is y bar for attack power? What is y bar for attack power? So just try to find y bar for attack power. What is y bar for attack power? You have to know what y bar is. So we go to our notes and we say, well, what is y bar? It says y bar is this. Not 50. That would be lowercase n. And they use capital N here. I hate that they do that. They use capital N at all times for size. So y bar is the sample mean. So look here under summary statistics are for samples. So y bar is what? Y bar is the sample mean. So we'd report the sample mean of attack power, y bar, is equal to what? 82.64. And lowercase n is 50. And then S, which is sample standard deviation, is 30.37. They just call it 30.38. What is p hat for percent of legendary Pokemon that are legendary? What is p hat? You have to look over here because p hat is for proportions, meaning sample proportion. So what is the sample proportion of legendary Pokemon? What is the sample proportion of legendary Pokemon? What is the sample proportion of legendary Pokemon, which would be p hat? And this is all from a sample size of 50 Pokemon, which is n equals 50. So what would be p hat? Correct. Great job, Noel. So that is p hat. So as you go through here, you can use, and sometimes people use slightly different notation, like Jump uses capital N for sample size. They just use size at all times. I don't know why they do that. Some statistician said, I'm going to use capital N, just means size. I don't want that little boop right there. So what you should be able to do is, we don't need the missingness, or lack of missingness, I should say. Okay. So what you should be able to do, especially working through this class, is you should be able to go here and say, this all comes from a sample. So what we would have right here is we would have y bar, we're going back to orange, y bar s, this is standard error y bar, this is upper of 95%, this is lower of 95%, this is lowercase n, this is missingness, NAs. You don't know all these yet, so if you're asked not legendary, we call that q hat. So this is q hat, and this is p hat. So that's kind of the notation with y bar being the sample mean, s being the sample standard deviation, standard error of y bar, we haven't gotten into that yet, the upper of a 95% confidence interval, the lower of a 95% confidence interval, the sample size equals 50, and missingness is often called NAs, capital NA. And then we have here the interest, the proportion we're interested in, p hat, and the complement q hat. So p hat and q hat add up to 1. So p hat plus q hat equals 1, or 1 minus p hat equals q hat. And that'll be coming up here very shortly as we get into proportion data. So you'll never really use p hat and q hat or p hat and y bar together. It's one deals with quantitative data and one deals with categorical data. So good questions right there. Very important to know your notation. Where's my notation, brother? Notation, brother. Okay. So let's go right here. 22, 23, Stat 201, Chapter 10, Homework, Question 5. Okay, administrators at the Texas A&M University, man, they love Texas A&M. We're interested in estimating the percent of students who are the first in their family to go to college. So what would be their estimate of that, Noel? You can't put the little character over it, but they're trying to estimate the percent of students who go to college for the first time. So what would that be in notation? This is good practice right here. The percent of students who go to college for the first time would be what? When they go and take a sample, they're going to get what from that? Don't worry if you're wrong. The percent of students who go to college for the first time from a sample would be what? Because it's a categorical question. So their estimate of the truth is going to be what? Don't worry about being wrong. Take guesses. The percent of students who go to college for the first time. The percent of students who go to college for the first time. So a good way to do this is say, is it categorical or quantitative? If you go to college for the first time, that's categorical. Close, it is a sample. It's going to be p hat. Because it's, do you go to college, yes or no? Kind of like the legendary Pokemon. Think you could ask, you know, are you the first in your family to go to college? True, false, which would get a percentage. Y bar is for quantitative data. So if you're doing quantitative, you get the mean of quantitative data and you get the proportion of categorical data. So this is categorical proportions and this is quantitative means. So, and Y bar estimates mu, and p hat estimates p. So we're trying to estimate the true proportion of people who go to college for the first time by getting a sample proportion right there. I have no idea. Go away, Copilot. We don't need you. They don't ask anything about that though, but there's lots to learn as we do this. So it says right here, several dormitories are selected at random. Now here's the thing, contact every student in that dormitory. I automatically know what this is. So they're talking to every student in the dormitory. Which sampling method is this? They're talking to every student in the dormitory. What sampling method is that? They're talking to every student in the dormitory. What sampling method is that? What sampling method is they have to talk to every student in the dormitory? Every student. What sampling method is every student? It is. Great job, Noel. Let's go look at that. Here it is right here. Oh, did we lose it? There we go. Doing a census means taking everything. Oh, my phone just rang in a weird way. Doing a census means we take data on the full group. So look right here. Clusters are put together randomly, like students are in random dorms. We take random clusters and we do a census on them. So we select several random dorms and contact every student in the dorms. This is 100% a cluster. And the census, I know, right? So the keyword is contact everyone, and that's going to be a cluster right there. That's your key. It could be a multi-stage. I hate it when we do multi-stages because it gets tricky, but it's going to be a cluster. And then they explain it to you right there, but we look for the keywords. Okay, so now we have 300 sophomores, 300 juniors, 300 freshmen. This college must be evenly distributed. So what kind of sampling method is this? 300, 300, 300. So you have to have your notes up. Make sure to write down the definitions. What kind of sampling method is contact 300 from each group? 300 from each group. What kind of sampling? Got different sampling methods, all different sampling methods, stratified, systematic. We got here cluster, simple random sample. And so which sampling method is this? Is it simple random sample? Is it systematic? You can see keywords as we go through it, like every kth. So systematic has that every kth observation. Simple random samples, we talked about like rolling the balls right there, where you select out of randomly right there. Everything has an equal and likely chance to be selected. So that's simple random sample. We talked about systematic, every kth observation. Stratified, you have to acknowledge a difference. And then it's not good guess. It's not systematic because that would always involve every kth observation, like every 10th, every 20th, every 30th from a random starting point. It's going to be stratified because you acknowledge a difference and then sample in accordance to that difference in the population. So stratifying is when you acknowledge a difference and then sample in accordance. So first you have to acknowledge a difference. So the first difference we are acknowledging here is a difference in what level of students. What is the difference we are acknowledging, which is going to tell us that this is stratifying. And then we're going to sample according to that difference. So what is the difference we are acknowledging between students to then make sure we properly represent this difference, which is stratifying. So what difference are class? Yep. So there's one group, another group, another group, another group. So this is definitely strata or stratifying. So this is 100% stratifying. I really like this question. And this is very much like test questions. That's stratifying. Computer generated numbers, select one of the first 25 names, and then contact every 50th name later. I think you got this, Noel. So from our notes, computer generation. So we look for key things in this. They're going to pick a random starting point, and then they're going to contact every 50th name. So I see here a random starting point, which is not required, but we have random starting point, random start, and then we have every kth name. So what is that going to be? Use your notes, good practice, don't look at their answers. They have a random starting point, which doesn't make it multi-stage. You always do this for this. When you pick a random starting point, you contact every kth observation. So what is that going to be? Which one of these is it going to be? Which one of these is it going to be? Cluster, stratifying, systematic. Yep. So beginning at a randomly determined point, you'll select every kth observation. So if you look over it, a random start and every kth observation. Kth is just a placeholder. So the key is you have to know the key elements of these, like systematic, pick a random starting point, select every kth observation. Sometimes they don't pick a random starting point. I wish they always did, but they should. And they're systematic. So really, that's an S tier question. That question right there is as good as it gets on understanding how to do them. Exactly. So the 25 is the kth, and you'll usually see, or the 25 is the, the random starting point is not the k though. The kth is a placeholder. Like we could have said every 10th observation after this, every 21st observation. So usually it ends in a th, because you have like every 12th observation, every 15th observation, every 620th observation. And then the random starting point is like start at observation number 25. So when you say select every 5th student who walks in the door, K is 5. Does that make sense what the K is? It's a placeholder. We could have called it L, every elf observation. It's just a placeholder for whatever this is. This is what K is right there. So it's like every 10th observation, every kth observation. So, well, no, it's not kth. Every kth observation right there. So that's what we're doing, is every kth observation. The th is what is commonly said, because you could say every 3rd observation. We don't have to start at 25. So you could start at 25 to every 50th. You could go to the dorms at 5 p.m. because you randomly select 5 p.m. and talk to every 20th student you see. So you'll always see a th in there. That's the key, is you'll always see this select every th observation, that's a huge clue for systematic. When you see select every observation, that's like the big clue. So let's do this one. Good questions, Noel, and good practice. Make sure to have those keynotes on which type of sampling method is which. Get it right. We made this easier, I think. People love that. Make things easier. Stat 201, chapter 10, homework, question 6. When you sample so that every combination of individuals in your population has an equal chance of being chosen, you are taking a what? Don't look at their answers. So we've got systematic, cluster sampling, stratified sampling, simple random sample, multi-stage. So you should have definitions of all these. You should be able to go through them in your memory. So you can see them all right there. Multi-stage is just some combination of all of them. I'm wearing the same Batman t-shirt. I like this Batman t-shirt. It goes through the wash every weekend. So simple random sample, systematic, stratified, cluster. Once again, to repeat what they are, simple random sample is when everything has an equal likely chance of being picked. Basically, things get random numbers, and then you just select random numbers, like when you have the ball machine, you roll it. Systematic is when we start at a random starting point. We select every kth observation. Kth is just a placeholder for every 5th observation, every 10th observation. Stratified is when we acknowledge a difference, like class level, and then we select 50 sophomores, 50 juniors, 50 freshmen, 50 seniors, if the class levels are evenly distributed. If we were to take commuters versus non-commuters, which is the difference we are acknowledging, we might take 70 commuters and 30 non-commuters, because I think people commute more. We look at the numbers of the population and then use that to dictate what our sample looks like. Cluster sample is when we take a whole bunch at once. Like a 6-pack of Coca-Cola is a cluster of Coca-Colas because those 6 Coca-Colas have probably just been randomly put together. So which one of those is when everything has an equal and likely chance of being picked, basically at random? Which one is it? Once again, don't look at their answers. Well, stratified, it does kind of do it. And stratified actually incorporates simple random sample within the strata, but simple random sample is going to be right here. It's going to be simple random sample is when everything has an equal and likely chance to be picked. It's kind of like where you have, my favorite example of it is when you have that rolly ball machine, and there it is right there on the screen. Here, we'll play it. So the thing goes away at the bottom, but it's that rolly ball machine, you know, the one where you put the bingo balls in, you roll it. Probably doing the same thing. It's past Brian. See how much, I think I shaved it that day. There we go. Past Brian. So it would be simple random sample, and good guess, Noel, right there. Simple random sample is when everything has an equal and likely chance of being selected. And it just means we give everything a number. We select those numbers at random. Last one right here, Texas A&M University. Man, they're big fans of Texas A&M. Gig and Maggie's. That's what they say down there. So I'm told. I was there for a while. Maybe I'll go. I don't have anyone to visit there. If I go back, I should fly my wife there. I should fly with my wife to there and get us a nice hotel or something, and we could stay at Texas A&M for just like a few days. She would love that. She'd get to see friends. She sees them at conferences too, though. But I don't know. Maybe I need to talk to that before I book a trip at random. What would be the difference between simple random sample and a random sample? Simple random sample has before it that you have access to the full population. We pretty much use them synonymously here, or these are types of random samples. That last question is a little bit tricky because kind of all of them give everything an equal probability of being selected. Yeah, small like mini vacation. Like almost if I did it for a weekend, I was like, we're flying down to Texas and just like, hey, guess what we're doing this week? We're going to Texas, but then still be in session. OBS disconnected. I think we're back. Let me know if we're streaming. Give me a yes if we're streaming in the chat. It said OBS disconnected, but I think we're still going. You never know. Are interested in estimating the percent of students who are the first in their family to go to college? Already got this one. Yes, thank you, Noel, right there. I got a little notification. The A&M student body has about 52,000 members. That is capital N. The A&M administration has a variety of ways of taking students in a sample. For each of these proposed reconnected. Oh, didn't know. Identify the problems. Publish an advertisement inviting students to visit a website and answer questions. Now, what I don't like about this is there's 2 answers here that I think are pretty good. What do you think it is? A, B, C, or D? A, B, C, or D? Which of these answers look good? And I think I know which one it is. I'm between 2 answers. I'm pretty certain I know which one it is. A, B, C, or D. Because we do mention this in the notes. A, B, C, or D. I'll show you where it is. Because if it's not the right answer, then it goes against the notes. Which of these answers look good? A, B. So I'm looking for two answers that are possible. Or which one do you think it is? You can give me which one you think it is. It might be one of the two. Because I'd be like, yeah, it's kind of both of those. B and A. Now, you could argue C, because you could argue if it's on the web, students who travel the web more might be more likely. We'd undercover maybe older students who aren't on the web as much. So there's ways to argue C. Technically, you could argue a lot of them. The one they're looking for, I believe, is going to be convenience bias. And if we go back to the biases in the notes right here, once again, trying to shout out the class, suppose asking students on social media, which this kind of falls under, you see how it's like a convenient way, ask all your friends on social media. So putting it on the web is probably a convenience bias. And even though we do tons of web surveys these days, inviting students to visit a website and answer questions, probably convenience bias, and we got it wrong. It's going to be voluntary bias. Really? First one wrong today. I was between A and B. It is voluntary bias because it did say inviting friends, inviting students. I put friends in there. People with strong opinions. That's what voluntary bias is. See, don't worry. I get stuff wrong every once in a while. I don't, like I said, it's between A and B. It's kind of more like A in the notes. Set up a table. Would it be considered biased still if you put it on the web for everyone to see? Kind of. It's just web surveys do hit this problem where like who's viewing it, who has access to it. So web surveys are tricky and often don't capture the whole of the variation in the population. So a better thing to do is to go to campus and talk to students on campus and get views of people on campus to figure out what people think on campus. Of course, now some students are completely digital, so that changes it up. Sampling, you can do whole classes on sampling. Like I'm sure someone here has had weeks doing sampling. Like if you're watching this, some of my students have weeks where it's like, how do we set up samples? How do we create samples? How do we try to minimize bias? We give you a small bit of the whole buffet of sampling. Set up a table in the student union and ask students to stop and answer a survey. So probably, once again, this is a little bit voluntary, but since they've already done a voluntary one, I'm going to go with convenience sampling. And it's kind of the same thing. I really get mad about this. And on the test, we don't put both on the question, so don't worry. It's convenient because you're getting the people you have easiest access to get to. That's what we call convenience bias. Convenience bias is when you get the people you have the easiest access to. Is that the full thing? They're just trying to show the differences between these two. Can I do similar? Publish an advertisement inviting students to visit a website. So it's an advertisement. So they're saying that would be voluntary because they're going to do it if they have strong opinions. Set up the table, convenience. I think this question is meant to just drive home the differences between the two, which they're so similar. I don't like this question because I got it wrong. That's why I don't like it. Let's see. Let's do a few of the quiz. Let's do a little bit of that quiz. I don't like that question. No, sir, I don't like it. They sound Ren and Stimpy. So assignment manager. Let me bring this over to the other side. How's your morning going, Noel? Excuse me. I was trying to find my mute buttons to sneeze, and I was like, gotta sneeze into my shoulder. Oh my gosh. I was like, where's the mute button? At least I sneezed away from the mic. Convenience bias is when you select people you want. No, convenience bias is when you select the people who are easiest to get to. Response bias is when you write questions in such a way that biases towards people towards a response. And convenience bias is when you get the people who are easiest to get to. Definitely check out right here. Suppose we only collect from people who are easiest to get to. I have an Excel exam, but oh no, that's all right. That's okay. I'm not sure how to study. Yeah, it can be tough sometimes. It's tough. And like definitely take these notes on these different like undercoverage bias right here. We got definitions in the notes on what each of these are. So check those out. Really good stuff. Let's do a little bit of the quiz here. Replace questions. Oh my gosh. Holy moly. Oh, you gotta see this. Oh my gosh. Look at this. Look at how many questions there are. Good. I only got 1 cup of coffee. That was my error. Now I'm gonna go probably get a Monster, and I'm trying to cut those out, but gonna do some of these and just review them. These can be so tricky. And what we're gonna do right here is we're gonna do some of these, but we're gonna show the answers because they can be really tricky. So let's put these in the notes right here. And quiz and Major League Baseball teams. I think they can change a lot of these too. It can be like a hockey team. If you notice, watch this, it'll probably say like a hockey team, a baseball team. No. Okay, not doing that. So here we go first. They are going unannounced and they're going to test all 26 players on a team. So they're taking a team at random and they're taking all 26 players. They are doing a what on the team. So they're taking all 26 players on the team. Think of another C word, not that word. And they're taking a what on a team. And that really tells us that they're doing a cluster sample. Because this is what you do when you do a cluster sample is you go in and you take a random cluster and or you can take multiple random clusters via simple random sample and you do a what on the cluster. So they are doing a what? Another C word, which means taking the full thing. So what are they doing on that cluster? What are they doing on it? They're taking a what of that cluster. Another C word. So in cluster sampling, things are randomly put into groups. We randomly select the clusters, and then we perform a census. C-E-N-S-U-S, a census. So when they said test all the players on the team, that's a census right there. Next we have, is this choice appropriate? Well, the teams aren't really put together at random. That's my big problem right here. In cluster sampling, you're supposed to have random clusters put together. I don't really see that here. So, I mean, it'd speed up the process, but it's not really a good random cluster because clusters should be random. So they say yes, an entire team can be sampled at once relatively easily, but all players couldn't officially be sampled on the same day. The team is selected at random, so it's not representative of all baseball teams. No, but this is, if you say the team is selected at random, then that's not the issue. So that's just wrong right there. I don't love this question. This is one of the ones. This right here, the 26 players, the no answers are just wrong theoretically. 26 players is enough to make decent estimates. Larger is always better, but that's just wrong. And this says, yes, the team is not selected at random. So that's just theoretically wrong right there, because if it is selected at random, that's good. And they even say it's selected at random, team at random. So that's just theoretically, that goes wrong with this. So this says, no, it's not appropriate. The team is selected at random. So this is saying there's a problem with the team being selected at random. So that is wrong theoretically. I really don't love this question because the answer should be cluster sampling might not be the best because teams have different makeups and the players aren't really random who are on the team. I would just suggest doing a stratified where we take 3 random players from each team. Does that make sense? Because in stratified, you acknowledge the difference and then you randomly sample from each of the strata. So it'd be better not to take a whole cluster of a team, but to stratify on team, because stratify is when you start by acknowledging a difference and then sample within each group representatively. So make sure to have those definitions. On the test, people just guess between strata and cluster. They're like, each deals with groups. Cluster is when you take the whole group, like taking a box of donuts is a cluster of donuts, but stratifying is when you acknowledge the difference between glazed donuts and filled donuts because they're different, and you take 5 glazed and 5 filled, but then you could do cluster strata where you take a box of glazed and a box of filled, because now you have a cluster of glazed and a cluster of filled, and the acknowledgement of the difference is the stratification and the boxes are the clusters. So well, you can. So that would be a multi-stage. So that would be a multi-stage with stratifying clusters. Each implies its own different things. So to clarify, cluster is when things are put randomly into groups and you take the whole group and do a census on it. Stratification is when things have differences that you acknowledge, like maybe someone's major. You can stratify on major, and then you select a certain amount from each group representative to the population. We have a lot of business analytics students, so we would take A lot of business analytics students in when we stratify. Maybe something like underwater basket weaving only has 2 people in it. Well, then you might have overrepresentation or underrepresentation of other groups because you take even one of them would be 50% of the underwater basket weaving major students. Acknowledging the difference between major and then selecting students from each major is stratification. If you took all of one major, which probably isn't the best idea, you'd be taking a cluster of major. Does that make sense? What a cluster is? It's all of one group, and the groups should be randomly put together, where stratification is taking randomly within each group to represent the population to guard against things like under/over coverage. So review the notes, take some definitions. These are tricky, and they take practice to know the difference between. Here we are with the next one. Let's do another one right here. We're going to review. And Noel, thank you so much. I want MuBot back. We got to throw some huge points when MuBot comes out. We got to throw MuBot a party for the following. I think there's a billion type of these questions. So sorry if you went to this question and it's not yours. But let's take a look at this one and see what they have. They're going to ask a lot of different questions right here. And I'm going to answer them all for you. I'll pause the video too, or try to answer if you're in the chat. Here we are first. A U.S. consumer magazine asked all adult subscribers. So right here, that's probably their population. They're probably interested in the adult subscribers of magazines, whether they had used herbal medicine treatments. This is the parameter they're interested in, which would be the true proportion of people who have used herbal medicine. Draw out what we just said and have a hard time imagining it. Oh, what do you want me to draw out? Yeah, I can try right here. If so, and if they had benefited them. So that's the parameter of interest, the thing they want to understand. For almost all the treatments, approximately 18% of those who responded, so that is the p hat, reported cures or substantial improvements in their condition. Notice how we go through here and we try to mark the important things, and let's see what they ask. What is the population? The last part we explained stratification. Yeah, we'll do strata versus cluster. I'll do a section on that. You got it. So the population would be subscribers to the magazine, all adults. Probably all adults, like I said, unclear. It doesn't have subscribers to magazines, but all adults is probably what they're interested in. What is the parameter of interest? Whether they have received help, the proportion of them who have gotten better, the proportion of them who have used and benefited from herbal medicines. Notice how we already knew we were talking about proportions because it's categorical data. And we were answering these before we got to them. What is the sample frame? So the sample frame is the group of individuals or things you have access to. So who did they have access to talk to? So Noel, do you know who they had access to talk to when they sent it out to all their subscribers? Who did they have access to get information on about US adults when they sent it to all their subscribers? Who did they have access to get information from when they sent out the survey to all their subscribers? Who did they have access to talk to when they sent it out? Exactly. They have access to their subscribers. So all the subscribers of their magazines. So because they can't reach all US adults, they want to understand all US adults, but they only have access to their subscribers. And they're going to say that that is representative of US adults, but maybe not. What is the sample? The people who responded, the people who actually gave them data. All responders to the survey. What sampling method was used? I would say it's convenience. Kind of a non-random, I would say non-random, unclear convenience. Those are the keywords I'm looking for. Because they really don't, they just send it out to everybody like a census, unclear, random, convenient. So those are my keywords. Voluntary, yeah, people with strong opinions. I should, convenience is basic. Convenience, that would have caught me. This one would have got me. I would have gone convenience. But it's voluntary because people with strong opinions are going to respond. It does have some convenience though. So that one I probably would have got wrong if I was going through this without the answers. Yeah, and once again, on the test, we never put convenience and voluntary in the same thing because voluntary means people with strong opinions are more likely to respond. Think of restaurant comment cards. That's a voluntary response bias or voluntary response sampling. Convenience means you go to the people you have the easiest access to. So I think there's some convenience here. Like you can argue a lot of these. You can't argue systematic because they didn't do every Kate. You can't argue stratified because they didn't acknowledge a difference. You can't argue cluster because they didn't take a whole group. I might even clicked unclear. Is the sampling method random? It's voluntary, so they should say suffers from voluntary response bias. So if it's voluntary, it has voluntary response bias. Nope. Who was left out of this study? People who are not subscribed. There you go, literally. Yeah, if we want to understand all US adults, then we didn't cover in our sample frame all people. And what type of bias is evident? So we have undercoverage and we have voluntary response bias. And voluntary response bias and undercoverage. So, because the voluntary response bias or voluntary sampling is a biased form of sampling. The sampling that we do is systematic, simple random, stratified, and clustering. These two create bias known as convenience bias and voluntary response bias. So both of those are not random. And you think because they undercovered people who don't subscribe, and then also it's convenient. They also kind of did convenience bias, if you ask me. But the two types of biases they have are voluntary bias, so it's not random. So they select who to do the test on. Kind of sort of, they selected their subscribers. So they undercovered non-subscribers. Who was left out? People who don't subscribe to this magazine. So since they don't have enough people who don't subscribe, they undercovered people. Non-subscribers are not issued. So once again, there might be response bias, there might be non-response bias, but they kind of make it clear with those last two, like, well, you know, we have voluntary response bias because it's voluntary response sampling, and undercoverage bias. So this bias right here alone makes it non-random. It's a little bit tricky of a question. That's a tricky one. And this is the same sort of one right here. We'll do, and I'll end with the pictures and stuff right here. We got time for a few more. These ones really are tricky, if you notice. Hence why I put the answers on, because it makes it easier and we just talk through it and we talk through the concepts. And once again, version 2. Let's check it out. Okay. Hoping to learn what issues resonate with voters. So what's the population of interest? See, it literally says down there, though. What is the population of interest? Hoping to figure out what issues resonate with voters. So that tells us that's the population of interest right there. Voters, people who vote, population of interest, the group we care about. Mayoral selects 3 blocks from each city district. Staff members go there and interview all residents. Noel, what is this? They've interviewed all residents from 3 blocks. The residents were asked to select the 5 most important issues. So the 5 most important issues is the parameter of interest. So what kind of sampling? I feel like with these questions, depends on who's picked. Kind of. We on the test, we try to make it as clear as possible. On the test, we're like super clear. So they selected 3 blocks, and they selected... they talk to all residents on those 3 blocks. So I think they give a little more complicated of an answer, but there's definitely somewhat here because they take all residents. On the test, what do you think the answer would be for what sampling method was used? They have 3 blocks. So they go to 3 blocks and they select all residents in this block and talk to all the residents in the block. So what kind of sampling method if they go to 3 blocks, which are random groups, and talk to all residents in those 3 blocks? Good review of the Constitution. Well, so the population of interest is all voters. And the sampling methods to pick from are simple random sample, stratified, cluster, systematic, and multi-stage. So what sampling method was used? What sampling method was used? We have simple random sample, stratified, cluster, systematic, and multi-stage. Cluster, great job right there. Nice job. I like it. It is cluster because they're taking all of the group. Let's go through here and check it out. They're interested in all people who vote in the city. What is the parameter of interest? The 5 most important issues. The parameter is the thing they care about. So the population parameter just means the thing they care about that they're trying to understand. So it'd be the 5 important issues right there. Next we have, what is the sample frame? So this is a little trickier one. This is who do they have access to? And they probably have access to all people in the city, right? All people in the city. All city residents. So all voters in the city. See, that's tricky. See, I could see how I get all voters in the city. That is tricky. That is mean on that. I did say all city residents, but that's a little mean right there. That one, I wouldn't put those 2 on the test. I wouldn't put those answers. What is the sample? Everyone who talks to them. So make sure, once again, to remember the sample is the group that talks to you. Oh, wait, what is... Here we go. We would say stratified? Wait. What is the sample for the study? Multi-stage. This is... Okay, this is where they get really tricky. Let me read this. What is the sample? Stratified sampling with each district being represented by 3 blocks. Oh, no. Okay, they're doing a multi-stage. How did I not see that? Okay, randomly selects 3 blocks from each of the city's districts. Okay, so they are doing a multi-stage. Okay, so now you would have another district over here where they select 3 blocks at random. And you have another district. So we're stratifying by district. The stratification is on district, and the clusters are the blocks. This is a really good example right here, Noel, because each of these that I'm about to circle in orange is a cluster. Or rather, I circled the strata. That's cluster 1, cluster 2, cluster 3, cluster 1, cluster 2, cluster 3. So they select from different districts. So this is district, maybe there's 3 districts. This is district, we'll go to blue. This is district 1, this is district 2, this is district 3. So district is what they're stratifying on, and then the blocks are what they're clustering on. So does this make sense with the drawing? They're selecting 3 random blocks and talking to everyone within the blocks, and then they're stratifying on district, because how many blocks look at my drawing, how many blocks? This is a block, that's a block, that's a block. This whole thing's a district. So that's a district up there, that's a district up there, and within it are blocks. How many blocks did they take? How many blocks did they take? And a block is like 100 people living on a block. So how many blocks did they take total? They took 9 blocks. But then they made sure, because they could have went to district 1, and in district 1, they could have taken 9 random blocks. Would this be representative if they went to district 1 and took 9 random blocks, and then they didn't take from any other districts? If they took from district 1 9 random blocks, and then from district 3 and 2 and 3, they took no blocks, would that be representative? I'd say not, because district 2 and 3 might be different and have different wants and needs. So what they did was they said, okay, we are acknowledging the difference. It'd be answers from only, not maybe the size of the area. It could be a small area, but it's going to be that they undercovered the other blocks, right? Or the other districts, excuse me, because this is the district and within it are the blocks. This is a district in my drawing, and this is the blocks. So the reason the blocks are the cluster is because they're talking to everybody on the block. They don't talk to everyone in the district. The district has 3 random blocks, and the district is where we acknowledge the differences, and we take 3 random blocks within each district. Does that make sense what a strata is? A strata is where you acknowledge the differences and then sample within the strata representatively. A cluster is when you take all of a group, like this is 100 people, and I'm taking everyone on that block, everyone on that block, everyone on this block, and we take 3 random blocks within the district, which is the strata. Does that make sense? It's a little tricky right here, but yeah. So hopefully that helps with the drawing. It takes review. So it is stratification. I don't like that they say sample. This is the real question. What sampling method was used? Using strata for the districts as strata and clusters for each block. I wish they said block. What they say right here? Oh, they say cluster. No. Oh, and they reversed it. Ooh, I think they have a typo. And the cluster sample within each district being the block. They really should have said block. That's mean. But this is wrong. Using cluster sample with each district, no. Using stratified sample with each district as strata. Districts are strata, and the blocks and cluster sample with each. This is a typo, I'm pretty certain. And cluster sample within. Okay, they do say within. It's not a typo. It's just with the blocks within. That's mean. That's tough. And it is random. If I'd seen this, it's random. It's very random. Who was left out? Nobody. The staff? Really? The staff? The staff interviewed all residents, so anyone they could not find was left out. Oh, anyone they couldn't find. That is so mean. Come on. I'm glad we're showing this one. I would have said no one's left out. The staff interviewed everyone. Because it says they interviewed everyone they could find. People they couldn't find. Come on. Oh, so we undercovered them. What type of bias is evident? It's only going to be undercoverage because we couldn't find people. Undercoverage. Yeah, so that kind of, they always allude to what the next question is. I've done a lot of these. So it's going to be undercoverage. Yeah, this one is way harder than any test question. But what a really good thing to know right here is, do you see how I instantly knew it would be undercoverage bias? Like once I saw this answer here, they couldn't find people. So that means these people were left out. They couldn't find them. So when you hear, oh, we didn't have this group in our research, that means you undercovered them. So undercoverage is when you don't have a certain group in your study, and the questions on these will often allude to what the next thing is. Like, what kind of bias is this? Like, what errors are there? Oh, they left people out. Well, then that means they undercovered that group. Oh, the question was worded in a way that pushed people towards a response. Well, that's response bias. They'll always allude to the next answer. Might be able to do this one pretty quickly. Here, we'll do one last version. Then I'm going to run and get a drink or something here. 101, 4 to 3. I like to make sure when I'm doing these, I give right answers. This is probably one of the hardest ones because it's a little bit subjective. And, y'all. So you get to see the answers. Okay, so state police set up a roadblock to estimate the percent of cars with out-of-date registration, insurance, and safety inspections. They usually found problems with 19% of cars. They want to understand all the cars. They're not trying to understand people because they're interested in the registration, which is on the car, and the insurance, and the safety inspection stickers. So they're interested in the cars. What is the parameter of interest? A bunch of different things. Is the car up to date? The safety things. That's what we're interested in. Out-of-date registration. So yeah, up to date. Yeah, see, that are not have stopped. It's of all cars. This would be, that's a sample right there. So they're trying to trick you right here. I don't know why they say everything. Up to date, oh, information. Yeah. Or it could say up to date or out of date. What's the sample frame? It'd be all cars that drive down this road. So all cars that come to the roadblock are going to be in the sample frame. All cars out at that time that could go through the roadblock. So all cars that meet the roadblock is the sample frame. Anyone who goes through the roadblock. What is the sample for the study? It's any car that stops, any car they talk to. Any car that stopped, any car they talked to is the group they sampled. What is the sampling method used? It's kind of a cluster at location because they're getting all cars at location. Does it say they stop all cars? And they're pretty much stopping all cars. So the sample method is pretty much like cluster at location. It's going to say unclear or cluster at location. Cluster. I was getting worried there. It's cluster. Because they're talking to all cars that stop there. They're stopping every single car. Yeah, it's random, but there's a bit of an issue when they go to like a location. I'd say yes-ish, but I have concerns about taking one location is not completely representative. So I'd say yes-ish. It's not known. Yeah, that's mean. That's just mean. I said yes-ish, but out of it in between, it is random because it's cluster and ish. Who was left out? No one's really left out, but doing it at this location is a bit iffy. So I would either say no one's left out, or doing it at this one location really leaves out anyone who doesn't go down that road. People who don't take that road. Yeah. First thing I'd see right there. People who don't take that road. What type of bias is evident? I mean, then you've got undercoverage. If you're leaving people out, so undercovering people who don't take that road, none. Oh, but non-response. I wouldn't have clicked that. Because non-response is in here, that's when people who differ in their opinions don't respond. I wouldn't have clicked that because there's definitely not non-response. So that, luckily they threw that on there, and I might have been like, nope, there's not non-response in this. What problem could you see in generalizing this? Just that they should have said there's some undercoverage, I think. They're going to say none. That's undercoverage! That's literally the undercoverage I was getting to. Oh my gosh. Oh my gosh. That's literally the undercoverage I was getting to. Well, you should have said there was undercoverage. Yeah, it's time, day, and location may not purpose. That's literally what I was getting to. And that's undercoverage. Man. I feel like we need to make changes to this quiz. It's my apology at the end of this. Some of these, I'm like, who wrote this question? The problem is, and I'll say this to end. The problem is a lot of these questions would be better just as a conversation, because there's subjectivity to some of them, and there's, written responses would be better. You notice my written responses mostly cover a lot of this. So yeah, it's like multiple choice just doesn't do well because, yeah, this is my least favorite quiz of the semester. My least favorite quiz of all of them. So least favorite quiz. There's a lot. We did a lot of the toughest ones. I didn't do like easy ones where it's just like you can just click answers. They're just trying to, I know, right there, Max, right? That's just mean. Like, that's easy. We know what sample statistics and population parameters are. Well, I'm gonna go get a drink. Go grab some Monster or something. Bye for now, everyone. Bye.